Okay, I think we're ready to go. Let me make sure we have sound. Yeah, I think we do. All right. Let's see. Last time we were in Fusion, and we were working on that upper hatch for this guy. Where are we at? Where are we at? Now we have an upper hatch, the wrong color gray. I think I do have a closer match color gray, but that's the one I put in, and it turned out it's kind of the wrong color. But the original hatch back here is also a different color from the main body, so I'm not terribly worried, but maybe I have something that looks a little bit better. Also, look, we've printed these in the correct color, these in the correct color, although I don't have the lines, little panel lines on them, but that's okay. We can add those later if we want to. Printed those in the right color, and we have fuel tanks now. So the fuel tanks, I started thinking when I was looking for reference images, it turned out that Thingiverse had already made fuel tanks, and there's nothing really particularly interesting. Let me show you about them. They're very similar to the other the missiles, except that they have this little cap. So the way they printed, you can actually see the seam line there, is the little cap is separate from the body. I printed it standing up, and it works pretty well. The only thing is, I did just download this one and print it, and this little connection point isn't quite as good as the one on the missiles, so they tend to fall off occasionally. But let's see if we can get out further. We're getting close, closer. We're still missing the canopy. That one is going to be a little bit challenging. It's supposed to be clear, right? And so FDM, 3D printing with plastic and clear don't really work that well together. You can get kind of translucency, and there are some processes you can do to get kind of clear, but there's not a good clear. So, and actually it's a tinted gray, but still transparent. So what I think we're going to try a couple of different techniques for the canopy, not today, but just so you know what we're doing. For that one, we have to model it. I don't have one. So we're going to have to basically kind of do what we did with this hatch back here, which I'll show you what I finished up, how I ended up doing that. We'll have to do basically that same process with this area, which I did scan that the same time that I scanned the area for the hatch. So I already have the geometry. We just have to model something to go there. It's a little more open because here I did have basically the two profiles to loft between, so I had a lot more guidance on what was supposed to go in there. So this one will be a little bit freehand, but we'll model something in Fusion. I may or may not show that process. I'll probably just show the results because I'm anticipating it being very similar to this process, which we did show. But then we'll print it in FDM for fitting because that's faster than the other processes I'm thinking of. But once we get it fitted to where it looks like it's going to work, then you can print relatively transparent stuff in resin. So we'll try to print it in resin. Sometimes the transparent stuff in resin wants to yellow, but since this is supposed to be tinted kind of a smoky gray dark color anyway, I think that'll be okay. So that'll be a thing we try. The resin can be a little bit brittle sometimes. You can add some flex agent type material to it to make it a little more I guess a tougher material where it's got a little bit of flex to it, not quite as brittle, but it does have to snap in back here and snap closed here, so I don't know if that'll work. Another thing we can try is a combination. I do have a little miniature vacuum former, so we could form the shape out of a sheet of plastic. I just don't know how we're going to get it to snap into the spot back here. So we'll do a couple of different things, see what works there. We may not end up with a super great solution for the canopy. I haven't even looked how much they cost on eBay, so I assume they're not cheap. So we're going to try and restore this guy with just printing. So far we've only got, we've made the rear wings, the front canards. I've printed those in black now. We've got the fuel tanks, we've got the missiles. So we've used a combination of Fusion and Tinkercad. We still have front landing gear, so got nothing here. So we got to do that. I did find online they have models already made for front landing gear, but they were pay models, and I didn't want to do that. Felt like cheating. These fuel tanks were free models on Thingiverse, and they work well enough, and they look more or less like what the real things look like. So I just downloaded those, and they weren't gonna making those weren't gonna give you any new information, so I didn't feel that was too big a deal. So we're pretty close to having this guy complete, or at least complete-ish. They still got some other, like this stick is supposed to be a sticker, but it's actually a piece of electrical tape. So we'll see where that goes. Let's look at what I did for the hatch back here. So here, this is our little hatch, what we ended up with. It even has the little notch here that fits into a little spot there. I think the notch could be a little bit bigger. Maybe if I print it again in the right color or closer to the right color, I'll widen that notch a little bit. But it fits pretty well. It does see that there's a little bit of a bulge right here that doesn't need to be there. But I'll show you once I get back to Fusion what we're dealing with here and how we could fix that if we wanted to. So here's what we have. You can kind of see if I turn all of the stuff back on, there's what it looks like in the scan. So this was off. So I do have several profiles. Now I have chopped it down using a couple of planes to kind of chop it into size. Although turns out that I didn't know this, or I didn't notice it, that these edges aren't actually straight. They're actually curved a little bit. So I had to go in and put this little surface right here to basically chop it at a curve instead of a straight angle like this plane would do. I put the little wing on here. I had no guidance on that other than pictures, so I just kind of estimated what it looks like, and it looks reasonable. It's probably thicker than the original one, but that's okay. And if I want to fix that bulge, then I added this profile. Oh, so in the stream I was trying to do the profiles as a surface, and that worked, but when I went to make it thicker, you know, to have some thickness to it, then it was not doing what I wanted it to do. So what I ended up doing was the top line here, well, it selected the whole thing, but the top line of that is from the scan, and then I just offset it. I think I did 1.5 millimeters to get it the right thickness. And so I ended up making these little profiles that are solid, and I did go into the solid loft and mesh there versus the surface loft and just create a surface and thicken it. So it did end up better to do this, but I was never getting quite the right shape in this area, and you can kind of see I've still got some weird shape deformed here. And so I added this profile. Well, I can click part of it. There it is. I added this one just kind of by eye, and I went in and I adjusted it like I could tell kind of what it should be just based on what the others were, and what the resulting loft looked like. But it looks like I've still got this point and this point a little too far out, and I need to manually move those around. So over here, there are there's the first one I printed, then got a little closer, the right size but no wing on it, and then I finally got this one to be where it fits and everything, but it's the wrong color, so I did reprint it in a different wrong color, but closer to the right color. And so this is where we're at right now. It took, I guess, 5 iterations of going back and forth, mainly to try and get that. You can kind of see there's a weird shadow in that groove right there, and then it starts getting better. These are actually, one of these had the straight sides, and then I had to curve it, then I had to shrink it a little bit. So there's a little bit of iterating in there. Each print was only like 25 minutes or so, so it wasn't terribly long. And so that was the process on that one. It was a little bit more on the let's get close based on having this scan data. And you can see we've got the scan data for where that canopy is going to be too. It's a little rough. I might try to use the more powerful scanner to get even more accurate results. And just we can see the difference. Although there's a lot of detail in here, but there could be a lot more detail. That other scanner though, my computer struggles to run it because it's collecting so much data at a time. And this computer is a little bit older. Actually, it's quite a bit older. So sometimes it struggles, but so I might try to scan it and see if I can get a little bit better scan, particularly for, whoops, I wanted it to slide, for this area where it has to snap into the body. So yeah, I think we need to, not today, but offline, I will go in and basically isolate this sketch. Which one is that? 16, I think. Go in and manually kind of like move these points a little bit to try and get a little bit closer shape to what I'm wanting, you know, stuff like that, and see if I can get that bulge more under control. So every time I do, now it's going to be a longer process because it's having to recreate everything. So you can kind of see that bulge is this line, this profile line right here, curvature line, I guess. If I could get it a little bit nicer, I think it would not be so bulged out. Actually, that's not too bad, but you can kind of see where these 2 points probably need to still come in a little bit because there's a little bit of a bulge right there. When you're dealing with stuff like that, you do have this inspect tool where you can put a zebra pattern on there, on the body, and it kind of gives you a easier to visualize way of, looks like maybe horizontal stripes or these, well, that didn't change the direction, they're in the same direction. You can kind of start to see what it might look like. I really wanted them to go the other way, but apparently they're not going to for me. Unless I can rotate the whole thing around. Maybe. So you can, there's some tools that you can use to try and see what these, see it looks kind of raised up right there. I think I need to move those points in a little bit. All right. So we're not going to do that because that's going to be a lot of fiddling, I think. So I don't want to just do that in the stream. But what we are going to do is check the chat. There's nothing over there. I'm going to close Fusion so that I can get some of my computer resources back. It'll take a minute to close because it has to upload the save file because it saves in the cloud. And so it's going to take a little bit. I think it's closing. There it goes. All right. Let's go over here to look at something while it's going. One couple of things we do need to do are we did want to do, what if you wanted to print a multicolor print, but you didn't have an AMS, so a automated material system that lets you automatically, without you doing it, switch between colors. I had shown, where is it at? I had shown this. I had shown this guy. Gotta see what I'm showing here. I had shown this guy, and it was a multicolor, you know, one of the little flexi sharks. And this was all one print, but this was done on a machine that did have a material switching AMS unit on it. And so you could actually get multiple colors all in the same print, and you didn't have to do anything. It just did it on its own. You had to load the filament in once, and then it handled swapping out the filament. So what if you don't have that? So you can't do this kind of multicolor printing very easily if you don't have something that's going to switch the materials for you in an individual layer. Either a machine that has multiple print heads on it, which there you have those machines. I've seen them with up to 5 print heads, and so each one could have a different material, a different color, whatever. Those are on the more expensive side. Or the AMS, where there's 5 rolls of filament and it automatically switches the rolls to whatever is needed at the time. That's what this one was. There is another one that I don't think it's a thing anymore. I don't think that it kind of was finicky, but it was one box that you added to your printer, and it would splice the filament together. Like, it would cut it, weld it together with heat, and then send it through the nozzle at the right time. Whenever it needed to switch filaments, it would just be, the new color would be welded on to the old color. That machine was called the pallet, and they had like maybe 3 iterations of that, and it did work, but it was requiring a lot of, you know, synchronization between the new filament coming in. Well, it's all one string of filament. It's just patterned into whatever color needed to be there at the time. It required a lot of synchronization, and it was a little bit clunky and a little bit on the expensive side. In this printer, you could get this printer with the AMS for the price of that one thing that you add to another printer. So I think they kind of abandoned that approach and switched to approaches like this, where one unit houses your rolls of filament and sends them at the right time, or the type of printer that just has multiple heads. But let's assume you don't have any of that. You can still get some types of multicolor. So here I've got a little step-by-step for how you can make your own multicolor if you only have a single nozzle printer. So this works best with things like logos or text on a plate. You know, you're going to print a nameplate or something. It works best in that kind of thing. But you find the image you want to convert or create the image, and then again, I'm going to use Photopea because it's open. Well, I don't think it's open source, but it's free to use, and it's online, and it's mostly like Photoshop on the basic level tools anyway. And we're going to vectorize it again, because what this process I'm going to do is I'm going to drop it into Tinkercad. Again, you can use other processes. This is just one way to do it. So we're going to get that SVG file, so that's the vector graphics format, and bring that into Tinkercad, make a 3D design, and import the SVG that we created in Photopea. And we'll have to rescale it because there's no real scale that translates from a picture to a SVG file. SVG files are kind of scale independent. So we're going to scale it to something reasonable. And then we're going to copy it, fill it, and not fill it, but change the fill mode to silhouette. And then we're going to drop that silhouette down. I'll explain it as we're doing it. And then we're going to bring it into our slicer, and we're going to actually go into G-code this time and add in some G-code to make our printer stop, tell us that it's ready for new filament, and then load in the new filament and continue printing. So that's what we're going to do. So I picked, as a simple one, like a 2-color logo, I picked the Saints logo. So I've already found an image somewhere. I don't remember where I saved it though. Probably called it Saints. There it is. So it's a PNG file, just the regular little logo. Let me show you where we're at over here. I guess we're on here. I'm just opening up the deal. Let me get this on the screen. Alright, more or less like that. We don't need their ads. We'll put their ads off to the side. Can't move them any further. Alright. So there's the PNG from the internet. I looked up Saints logo and found one that was pretty clean, and we want to print this. Now this is actually 3 colors if you include the white. We're just going to do it as 2 colors, and it'll be fine. But you could do a similar process to what I'm doing. I'm just going to show you a basic 2-color process, but you could do as many layers as you wanted to. The idea is going to be we're going to print one layer of one color, and then we'll change out the filament to a new color, and we'll print on top of that layer we just finished, and that'll be the new color. So the layers, the different colors are going to be stacked just like the layers are. And so you could keep stacking layers on top of one another to create a more than 2 color print if you wanted to. So first I'm going to remove this background. So that's this little magic select button right here, and we're just going to select the white, and it automatically selects all the white. Hit delete, and now this little checkerboard is saying that there's no information there. So now we can do our image vectorized bitmap. There's our resulting bitmap. I'm going to say that this only needs 3 colors. Is that right? Well, yeah, that's what ours will look like. I think it's including maybe nothing as one of the colors. So if we put 4 in here, we'll get the white back. Yeah. I don't know that we need that or not. Ours is really just going to be 2. I'm going to use the coloring book option. It seems to make it a little more printer friendly, but you can kind of see the difference there. Just makes that border a little bit rounder. I think it makes the outline a little thicker, like a coloring book. I don't want polygon. That makes it kind of rough, and you can actually change the amount of roughness. I guess that could be a cool effect, right? If you find the right combination of how rough to make it. Let's see. That's too rough. Something like that. You know, if you were going for kind of a very faceted look, you could change that roughness. I'm not gonna and select the polygon. I'm not gonna do that. I'm just gonna. This looks good. So now we've got a vector, and in fact over here you've got the individual layers. So you could export each one of those individually and kind of manually assemble all the different colors you want. Maybe you want more than 2 colors. Since we're only doing 2, it'll be fine to just do it this way. So I've got all the layers on, and we will file, save as, or export as rather, SVG, because we want that vector format. You could try to manipulate the size here. We're just going to manipulate that in Tinkercad. So save. We could sign up, but we're not going to do that right now. Then we go to Tinkercad. Now I've already logged in to Tinkercad. So here's our little work plane, and we've got some stuff off the screen. So let me resize to get everything on the screen. There we go. Pretty good. Import, and we're going to find that vector file, which is this one. There it is. And again, you could try to size it. We're not going to worry with that. So yes, it is way too big. So we're going to select it, hold down Shift, and kind of manually get something more reasonable. We'll also be able to scale it in the slicer if we want to. So depending on how big we want this thing to be. So this would be kind of interesting to print by itself, but all the places that there are no material is just kind of empty, so it would really just be an outline. So to fix that, we'll select it. We will duplicate, which is Control D, or I think maybe this copy. I guess that's also the same thing. We're going to do duplicate though. Control D. So that's basically copy and paste. Now there's 2 of them. They're on top of each other. And that second one over here in the fill mode, we're going to change that to silhouette. There's several options here. And what that'll do is it'll only take the outside part, and everything inside is basically filled. Now I do see I've got some weirdness. Look, there's a little weird jaggy thing right there. That's an artifact from our vector conversion. Maybe we could have fixed that. I think it's so small that it's not going to matter. So now I've just got one big blank, but I could go in here. Actually, there's the 2 of them. There's 2 things stacked on top of one another. One is the solid, and the other is the outline. Let's line them back up. Let's make them I am going to print these, and I'm thinking I'll print them at 0.2 millimeter layer heights. So let's make this, instead of 2.64 tall, let's make it something reasonable for a even division by 0.2. So I'm going to make it 3 millimeters. And then let's pick the one that's solid. Oops, let's unselect them. Let's see, that's the solid one. Let's make it also divisible by 0.2, since that's our layer height that we want to print at. And let's make it, what would be something smaller, 1.6. And now when I line them back up, that's kind of what I'm thinking I'm going to get. I'm going to get, and if I change the colors, let's see, let's say that this one is, maybe that's a black color, and this one is a gold color. So somewhere in there. When I line them up, that's what my print's going to look like. Okay. Right now they're two separate files, so I am going to Control A to select everything, and then I will group them. This will turn them all the same. Oh no! Yeah, it changed them to all the same color, and that's what it will look like. Now we can export that as a STL file. Oh, I should have opened Cura. I haven't opened Cura. Let me get it going. And let's prepare it to actually print. Now my printer over here, the print material that's in it is broken, right? So we're going to have to unload that. Plus it's green, which is not really one of the colors we wanted to print. I don't know if I have a, we'll have to see if I can quickly find any kind of filament that looks like it's going to work here. But all of them will work. Some of them will not look like the Saints logo. So we'll get that running and we'll change out this filament. Cura is still loading. All right. Apparently we can update. We will do that later. So here we need to bring in wherever I saved it. I don't even know what it was called. What did it call it? Fantastic Bruticus. We got to find Fantastic Bruticus. Must have put it in downloads. There it is. All right, so there's our little print. Let's make sure we're actually printing at 0.2 because that's what I was thinking we were going to print for the when I was figuring out how thick to make it. This size looks kind of reasonable. 2 walls is fine. Top layers of 3 each is fine. Infill, that's also fine. That's a PLA temperature. We could probably print a little faster, but we'll leave it there. It does need cooling because it's PLA, and we'll use that skirt. So that looks okay. Let's slice it and preview. It says it's going to take an hour. Let's preview it. And this is what, oh, I think ironing is turned on. Let's turn that off. Ironing would be interesting, but it's just going to make it take even longer. So now let's slice it. So 51 minutes. All right. So if we leave it like that, it's gonna print our 15 layers because we wanted it 3 millimeters tall with 0.2 millimeter layers. So that's 15. Now, the first layer is layer 1. That's going to be important later on. There is no layer 0 in Cura. And then what we're looking for is where does it start printing the other color. So it looks like right there is the first appearance of the other color, that little line. You can kind of start to see where it's doing the raised part. So that's at layer 9 if you start counting at 1. Layer 10, through 15 are just the rim on the top. If for some reason you have some features that are not being picked up, I don't really have any really thin features on here, but maybe you've tried to write some text and it was kind of small and it doesn't slice. What you can do is look for the word thin in here, and there's this option, print thin walls. Select that and it will force all the stuff to be printed even if it's smaller than the slicer thinks the printer can actually do. So in this print, it doesn't really change anything. There might be some differences in these corners possibly, but sometimes you've got features that are too small and they don't show up in the slice. So because they're smaller than your line width. So if you're having that issue and it's just you want those to print but you don't want to change the line width, then look for the print thin walls feature and that should pick them up. I don't think I need it on here, so I'm going to turn it back off. But in general, you don't want it on, but sometimes you have to have it to pick up some of those thinner pieces. Alright. Looks like our printer might be ready. Let's see if we can get connected to it. Remember, this printer's running Clipper, and so there are some things I can do on the printer panel itself over here. Like I could go ahead and change the filament temperature here so that I can remove. Well, let's see. There's a we'll just do it here. There is a preheat PLA, but I'll just manually change it to something that will melt PLA. Oh, hold up. I've got to connect the printer. While it's heating up, let me quickly see if we've got some filament that will work as far as colors go. So I don't have a good black that's not already loaded in a machine. So I found black polycarbonate, black PETG, and I found black conductive. So this is actually electric. Well, it's sort of conductive. It's not like a wire, but it is conductive and it will conduct electricity. And it is black, so we could use that, but I don't really want to use it on this. I did find a copper. Well, I guess that's more. I don't know what color is it called. I don't know. It's a silk copper. It is called silk copper. And I found ABS. What's this one? Oh, look, here we go. Here's some PLA. So we can use these two. This is not quite the right color. I found the perfect color, but it was PETG. So obviously this printer can print PETG and can print all these other materials, but sometimes different materials won't stick to each other, and PLA and PETG really don't stick together too well, so it would probably come apart. So I did find these two. I think these will work. So now it's a matter of, do we want to print the copper first or do we want to print the black first? I think what we'll do is we'll print mostly copper and then black outlines on top of that. So let's get that loaded. We did finally get connected to our printer. So let's get rid of this green. Now, some materials, not really PLA, these are PLAs. PLA is not as bad, but some materials, if you leave them out, they will absorb water from the environment that they're in and become brittle. I think I showed you, well, that's what happened here. Remember, it just snapped just sitting there. In fact, let's see, it's heated up, so let's see if we can get that out of there. So some materials will absorb moisture and not print very well. PLA, it's okay in general, although it will get brittle and not print too well even if it sits out. And these materials that I just found, who knows how long they've been sitting out. So it's possible that they're not going to print too well. There's two major signs other than just the print not looking that good. One of them is that it's brittle, so it just snaps really easy. The other one is when you're printing, if you hear popping sounds, like Rice Krispie popping sounds, then what that is that's the moisture in the filament boiling out and popping, coming out of the nozzle like little pockets of steam. So if you hear that, then probably your filament has too much moisture in it. The other visible sign, like if you're printing away and you've got all these strings that you really think should not be there, you've adjusted your retraction settings, you're not trying anything that looks like it should be really stringy, then that could also be something where there's a lot of moisture in the filament. So it's possible these filaments that I've rounded up will fall into those categories of having absorbed moisture. Actually, let's turn this the other way. And not print too well, but we'll see. Let's back this out. So I'm going to hit extrude in reverse, and so retract actually. See if we can get some of that out of there. And this is the direct drive setup. So let's get that out of there. Oh, this in the background, that kind of looks like it could work. We'll talk about that filament in a minute. Let's load up this. So typically what I do is on the end where we're at. On the end where I'm loading, I'll cut at a pretty steep angle. You know, something like that, to give it a sharper point that makes it easier to get into the feeder. Alright. Now let's extrude, I don't know, 50 millimeters maybe. Actually, let's move the Z-axis up some, so it's not sitting right on the bottom. There's green in there, and so there's still green in the nozzle, and I want to purge a lot of that green. Alright, you can already see, I don't know if you can see on the camera or not, I can see in person that there's the silk color coming out. So we'll let it purge a little bit. Now we're not ready to print. We actually haven't even sliced it yet. Or well, we did slice it, we didn't save it. So over here, right now, we could download this, save it to disk, which we're going to do, and we'll save it on the desktop. Let's call it something that I can recognize, though. And this is the G-code file. Okay. This does not tell it anything about changing filaments. There are extensions that will let you go in and they will add in G-code, although all the ones I've ever tried for this process don't always work. Like they use a G-code command that the software doesn't recognize or whatever. Yeah, so yes, PLA. So it's funny you mentioned syrup. The comment, in case you didn't see it, one time when I was changing filaments, my printer started to smell like syrup. It was going from PLA to PLA. PLA is made from corn. and it does have a syrupy smell, like corn syrupy smell. So PLA, polylactic acid, one of the main ingredients is derived from corn, and it will smell like syrup. Sometimes it smells like an oil type of thing, like corn oil or something. So it's not bad. It probably means it's extruding really fast, or you've pushed a lot of filament through, so you're getting more of it at once. But no, PLA kind of does smell like that. In fact, I noticed, and obviously you can't, because you can't smell what I smell right here, but this smelled that way too. So no, it's not bad. That's kind of normal for PLA. Let's see. So there are, like I was saying, there are extensions that will tell you to, that you can just click a button and it will tell you to, or it will add the G code to tell the printer that it will change colors. Like I was saying, those tend not to work for me for whatever reason. Maybe I don't use them the right way. So what we're going to do is we're going to go into, I just saved this to the disk somewhere, so on my computer. We're going to load that up as G code as a text file. I'm going to use Notepad. Let's see. Let's open it. I'll get it on the screen in a second. I just got to find it. Where I put it. Oh yeah, it started with CEV Saints logo. There it is. Okay. Yeah, we're on the screen. Oh, there's another comment. Smells like pancakes. Yes, it really does. At least most PLA does, except for the yellow. The yellow to me smells horrible, and it's a little obnoxious. Anytime I print yellow, I move it away. I assume that the when they make filament, it's pellets of plastic, and to color it or to add features to it, you add different pellets, so the colorants, and they're super saturated colors or whatever. So you might add one pellet to one pellet of colorant to, I don't know, 1,000 pellets of base plastic. I don't know what the ratio is, but for whatever reason, the yellow colorant to me is not one I like to be around when it's printing. The others tend to smell like syrupy oil kind of stuff. Here's the logo G code. So you can actually read this. Like, it's, I don't know how many lines, 50,000 lines of code. But it's all readable code. G code is stuff you could technically write yourself. You know, you've got, all of these are comments with the semicolon. Those are all comments. And then some of these are not labeled G. There are some M's in here. So the M's are typically like machine codes. They're telling the machine some kind of setup thing. And the G codes are telling it to go to a certain location. So that's kind of the way the G code is set up. So sometimes you have to tell the machine to heat to a certain temperature or display a message or something like that. Those are usually your M's. And then the G's are when the print head is moving around for the most part. So here are our 15 layers. Here is one detail. When we were in Cura, actually Cura's right here. Remember, we scrolled to the first layer and it was layer 1. So in the G code, wherever it went, the first layer is layer 0. So things are off by one layer. So we wanted, I've already forgotten now, we wanted to change at layer 10 maybe? So 9 looks like it starts, 10 is definitely the other color, so maybe we'll start at layer 10. Since this layer 10 started at counting at 1, then in here, well, not in here, in here, that's layer 9. So we could scroll until we find layer 9, or we can do Control F and just look for layer. Actually, it's already looking for layers. Oh, because I have it highlighted. There's 2, 3, 4, 5, 6, 7, 8, 9. So that should be where we want to switch at, right? If we started counting at 0 in the G code. So there's layer 9. Before we print layer 9, all of this is telling it to print the different things for layer 9. What I've got is on canvas. So over here, I've got this code already written. And this is kind of generic code for Marlin. So Marlin is the firmware that your printer's using. And if you have access to Canvas, you can just cut and paste this. It's on today's class thing. Otherwise, you have to type this in. And we will paste it in right here. So I'll kind of separate it. Now it's formatted way different, but we could clean it up if we wanted to, just to make it not quite so weird looking. But the formatting of it doesn't make any difference at all. Whoops, well, that would make a difference if I erase the comments. Or erase the comment semicolon. I'm just trying to get it all well, not that. Got in too big of a hurry. Alright. So what this does is, first of all, it switches, it's a G command, it's not actually going anywhere, but it's changing the way it moves. So there's two major categories for positioning, and it's the same as Excel. If you think about when you're copying formulas in Excel, and you can either do a relative or absolute copy, same thing here. You can do relative positioning, so you can tell it to move a certain distance, or you can do absolute positioning and tell it to move to a certain point. And so we don't know, actually we do, it's right here, but without going in here and looking at where was the print head last, this is the X and Y coordinates of the print head, where it last was, we could just say, no matter where you're at, switch to relative positioning mode, so that's what G91 does, and then go, this G1 is a movement command, so it's actually going to move now. Change your Z-axis by 10 millimeters. Now, I made the comment lower the bed. Most of our printers, the bed does not move up and down, but that's what some of the earlier printers did, is the bed moved up and down versus the bed moving and the axis, the print head moving up and down. So lowering the bed is the same as raising the nozzle. So I'm going to raise the nozzle 10 millimeters above the print, wherever it's at. Go back to absolute mode now. Tell it to go home, so it's going to move the nozzle to the corner so that it's not dripping on your part that you just printed. This, I'm going to even put a comment here that it may not work with all printers, but most of your printers in the Ender Marlin firmware style printer, M300 makes a little beep sound so that you can hear it. And then M0 lets you write messages to the screen, so to this screen here. Now, I don't know what that'll do on this machine running Clipper. It may not like that. In fact, it may not like any of this command at all. Actually, now that I think about it, it may balk at this. Clipper does not use Marlin G code necessarily, so some of these commands, hopefully it will just overlook them and say it doesn't know what to do with them and ignore them. But the G commands it should know. Now we go back to relative mode. And well, let me tell you here what it's waiting for. And this may hang up a Clipper printer because it doesn't interface with this panel the same way. So this may not work on this particular printer. It'll work on a regular printer running Marlin, but this printer is not running Marlin for the firmware. So we'll see. Relative positioning mode. Extrude some of that new filament, basically to make sure that it's purged and you've really switched to the new color. It puts this little message on the screen so you can click the button to restart it. It goes back to the right Z height. It goes back to absolute mode, and then it goes into the rest of your print. So You could alternatively sit at your printer, wait for it to finish as much as you think it needs to, and then in the menu here you can just tell it that you want, there's a change filament button in your menu, and you can just wait for it. So the only problem with that is you have to be sitting there watching it and hoping that you catch it at the right time. So back over here, we just inserted this for our change filament, so we could write a little comment, change filament. Save this again. I am working in actually this is Notepad++, but you don't want to load up your G code into something like Word or WordPad or anything like that, an actual word processor, because when you save it, it's possible that it's going to add in all sorts of meta tag data, like when you saved it and who the author was, all that kind of stuff. That's going to really mess up the G code, because the printer really doesn't know what to do with that stuff. So that's why I'm working in Notepad++. Notepad would be just as fine. I actually do recommend Notepad++ because you can do a lot of other things with it. Editing code. If this were some language, then it would be formatted more like a code versus just G code, which is more or less straight sentences. Well, not sentences, but commands. Let's save it. Actually, let's save as. And we'll put it on the desktop with, call it, we'll add change. We can't put a plus symbol in there. Put that in there. And we can close that. We can find our printer. All right, so again, I think that we're probably going to have problems in here with Clipper and interpreting some of those commands, but we'll see what happens. We should get the first, the first few layers printed. Let's load up our G code. I put it on the desktop, and it's got the CE because it's a Ender 3, Creality Ender 3 Thanks logo with the change made to it. And we'll start printing it. We won't actually be able to finish it. I think class will end before we finish it. But that would be the process. So it's going to heat up the bed and the nozzle and hopefully start printing here shortly, and we can come back and see what the final print looks like if this printer will do it. If it won't, I do have a printer in the room back there that runs Marlin that we can print it on. And you can see, and I'll show you next time what it actually ends up looking like. So in the meantime, let's look at, I did want to show this filament here. So this filament is just a little sample. It is sparkly. So let me see if I can focus on it. I don't know. Yeah, maybe. You can kind of get the idea. There's glitter in the filament. So these are pretty cool. They come out neat and all. They're usually PLA, some of them are PETG. What I want to say about this one, though, is that if you're printing one that does have some of this glitter in it or something like that, we've already talked about the hardened nozzle thing, but these filament types with the glitter in them, you almost definitely want to switch to a larger diameter nozzle. So this one has a 0.4 millimeter nozzle in it right now. I would be hesitant to try and print this kind of material with the sparkly stuff in it on that size nozzle, because it's just too big of a risk of it, one of those sparkles, the glitter, getting hung up in it and not extruding. So if you want to print, they're pretty neat filament types, but switch to a larger nozzle, 0.6. We did a nozzle change a couple of weeks ago, so you can go see how that works. Not sure what my printer's doing. It just stopped right here. It may have already run into some G code it didn't like. I don't know if it pre-processes it, and I think it might have. So I think this printer is not going to print our it's not going to print our multicolor deal. I'll print it on the printer that runs regular Marlin, and this is just not up here. I'll have to show you that later. So let me cancel this. Maybe it's just waiting on the bed temperature to come down, because it had overshot. So maybe that's all it's waiting on. It might still do it. I'll give it a chance here because it is overheated on the bed temperature. I'm not sure why it is. Maybe I had it set too high before, and now it's slowly dropping down. Oh yeah, there it goes. So it's going to at least do the first bit, so that's good. Although now I've told it to pause, so it may stop here in a minute. I don't know. Alright, so it should be resuming. So that was its pause. It was going to the back corner to pause. Now it's going to print. So it'll at least print the first layer. So again, it's printing the perimeter of that skirt. So look, it's not sticking down. I'm going to raise up the bed a little bit. That side's sticking okay. That side was just a little low. That looks like it's stuck down better. That's why I print that skirt usually on printers like this. I didn't have it probe the whole bed because that takes another minute maybe. But if you're not doing any kind of bed probing, then that skirt helps you. You can go in there and manually adjust as it's printing that skirt to get your part more likely to stick down. Because it doesn't really matter if the skirt sticks or not. Plus the skirt is a nice purge. It gets the filament flowing out of the nozzle better. So there it goes, printing that. We'll see how far it gets. I don't, well, class will end before it gets to the filament change. All right. While it's doing that though, there are, let's see, I did want to show you this. So you can, maybe you don't want to copy a logo, you can just do in Tinkercad, you know, you can do manual, there's 3 millimeters, make it whatever size you want. There's a text tool, and you can just put whatever text you want on it. Make it however thick you want it to be. Maybe another 2 millimeters. And you can center these things. Here's the little align tool, and center and center. And group them together. And so you can make your own. The main idea is that you've got different levels of where you can change filament colors. There is one other tool that I'll show you later that, not later today, but later in the future, that it will print very multicolor things, but it's a little more setup. It's called HueForge, if you want to look at it ahead of time. But, well, I guess we can search it now. It can print very multicolor, but it just takes a little bit more setup. It's not 100% free. I think there is a free sample you can use, but the cost is like $20 or something. Let me see, $24. It's on sale. So this is a way that you can create flat images that are these are all prints. These aren't pictures. These are prints. Pictures of prints, I guess. And this is the one that you can download and print for free. This little guy, the astronaut. But it's a pretty cool process, but it takes a little bit of setup to get working. The other thing I wanted to show you is, I don't know if you have messed around much with any of the AI mesh generators. You've certainly done an AI image generator at some point, more than likely, or you've at least seen them. But there are AI mesh generators. So Maker World has Maker Lab, which, let's see, some of these you can make little Pokemon style monsters. You can make a statue from a picture. So it does have some there, but I ran across one. Well, let me show you the one that most people are. It's the more developed one, I guess. Mesh.ai. This one is a. I think it can do either text to models, or you can do image to models. And it's been around for a while, and it does a decent job. So it does a pretty good job. Also, yeah, it can do rigging of characters, and you can actually make your creations move around. But these are all models that were created from a text prompt or a image and text prompt. So pretty good, like decently good. But I ran across one that is kind of the leading edge one. It was a research paper that I saw, and it's called Spark 3D. If you go to archive, that's where the actual paper is. But they've got a demo here, which I opened. I think this is the demo. So this image is just created from maybe ChatGPT, I think is the one I used. One of the AI. I'd ask it to create a image of a treasure chest on a white background, and that's just what it spit out in a fantasy environment. I don't remember what the entire prompt was, but it spit out this picture. And then I loaded this picture into Spark 3D, and this is the model it generated. I mean, that's a really nice model. It's not 100% printable. Like, you've got this little buckle over here, handle. That would be hard to print. You'd have to change that. You've got these feet, which look neat, but they make the bottom raised up, so that's not ideal for printing. This little overhang right here probably is going to droop, so it's not set up 100% for printing very well. You'd need to modify it, but that's a really good model. It's even picked up some of the texture for the wood in there. So this is pretty high quality model. Right now it's in the kind of beta phase or alpha phase, maybe. Probably beta. I don't remember what it said. But the general process is you create some image, ideally on a white background so that it's not trying to get confused. What these do is, I talked a little bit about photogrammetry, where you take pictures, a bunch of pictures. I showed you the Lady of the Mist. I took a bunch of pictures around the Lady of the Mist, and the software used all those pictures to figure out what the object must have looked like from all these different angles. So what these are doing is they're taking one picture, and then they're using AI to generate the other pictures, and then running that through a algorithm, sort of like photogrammetry. Now this one is more advanced. If you read the whole paper, they talk about what they're actually doing. But this one is giving you a lot more detail than any of the other ones currently, and it looks pretty nice so far. This generation took, I think, about 3 minutes. So between me loading up the picture, hitting generate, and then 3 minutes of processing to get this, and then it lets you download it. I actually haven't downloaded. It's going to be a GLB file, so not everything opens GLB. It's similar to, I think Mesh Mixer can. I'm not 100% sure it can, but let's see. I have downloaded this, so let's see. I don't remember what it was called. Where in downloads, I guess. Yeah, it doesn't show up. Yeah, so GOB is not one that Mesh Mixer can download. So you would have to use a different piece of software from Mesh Mixer to actually open this file, but or convert it to a SDL file. But pretty good pieces of software out there. So you can generate all sorts of models. It doesn't make them specifically for 3D printing though, so they could have cleanup that you need to do, or you have to add support or something like that, or very carefully prompt your image generation so that it creates more printable models. Like this one, you would have some issues with some of these overhangs, I think. All right, or printed in resin where that's a little less of an issue. You still have to deal with support though. So I just wanted to show you that because these AI model mesh generators are getting really pretty good. Meshy, not too bad. Whichever one, wherever it's at. I don't know. Oh, there it is. But there's a level of difference in these models, like the geometry behind these models and the geometry behind that Spark. So you can kind of see there is some detail here, but it's not the same level of detail as what Sparked or Spark 3D, whatever they want to say it, is generating. So if you're interested in creating some models from scratch, this would be one of the optional assignments you could do. You could use one of these tools to generate some kind of model and print it. All right, let's look at our printer. It's still going away. It has not gotten far enough along to change filament, so I don't know what it's going to do when it gets to the G code that we inserted on this particular printer. But on most printers, it will pause, put you a message up here, even play a beep sound telling you that it's ready. And then you'll have to manually, remove this filament, put your new filament in, and then it carries on with the printing. But I kind of suspect this one's just going to stop. Or maybe it just blows right through all that G code we inserted and we just get a copper silk logo with no color on it at all. All right, next time will be Wednesday. I think on Wednesday, I'm not sure exactly what I've got planned for Wednesday. Oh, I think it's this. So, so part of our restoration of this guy is the front landing gear. Part of the front landing gear is tires. And these are rubber tires. So we're going to have to start printing a flexible material. And so I'm going to use, now this is the wrong color. I do have the right color, but this roll was smaller. So this is TPU. And so it's a rubbery material. This one is more the stiffer kind of TPU. But they make much more flexible stuff. But it takes a little bit of tuning to get your printer to print TPU the way you want it to print. Now in this printer we've got the direct drive set up, so it's going to be better at a flexible material because it doesn't have a very long filament path for the flexible material to get wedged in or be a spring inside that filament path. You can print the TPU, particularly this kind that's a little more rigid. It is flexible and it is rubbery, but some of the TPU is like a rubber band, so it's super flexible, and you almost have to have one of these direct drive systems for that. But the Bowden tube, like this was originally, where there's the tube coming from over here, all the way over to the feeder or to the print head, you need some of the little bit more rigid TPU. There's also a flexible PLA that's basically the same flexibility as the more rigid TPU. So if you look at TPU and want to buy some of that, it tells you the shore hardness of it. The higher that number, the more rigid it is. The lower that number, the more rubber band it is. I am not going to be in my office today, but I will be some tomorrow, but not today. All right. I think that's probably enough for today. We will see what we end up with this logo. I'll print the right one. Even if this one doesn't work, I'll print it the right way. But we'll be back Wednesday.